Hello, everybody. Gary Mrozinski, and welcome back to Chapter 1. This is Part B. We're going to be constructing an economic model. Now, a model in economics is similar to a model in other fields of study, such as biology or physics, where we are creating sort of an artificial representation of reality that we can use to learn about reality. So that's what we're doing here. So this will be an economic model of an economy, such as the US economy. What we'll be learning from this model is the idea of scarcity, which we've talked about, the scarcity of resources, productive resources, or the limited nature of productive resources in an economy. Trade-offs, which means if within an economy you're producing more of one thing, then you need to have reassigned productive resources out of producing some other thing. So you're sacrificing, there's a trade-off. You're producing more of one thing but less of another thing. And whenever there's a trade-off, there is an opportunity cost. So the opportunity cost of producing more of one thing in an economy, which you would do because people want more of it, then the economy has to sacrifice production of other things. Because again, you have a limited amount of productive resources such as workers or labor. All right, so these are the things we're going to talk about. And what we usually do with an economic model is we take a more complex reality and we simplify it for the purposes of learning about the economic concepts we're trying to learn about. So the economic concepts are usually some sort of economic principle, or again, in economics, we call them laws. The law of fill in the blank, the law of rising opportunity costs. Spoiler alert, that's what we're going to learn about in this model. So this is the production possibilities model. What this means is there are lots of possibilities within an economy to produce different types of goods and services. And of course, as I mentioned, we're going to simplify that and consider a small number of different possibilities, but still that's the point. There's lots of different things you can produce, and you can produce varying quantities of each thing by reassigning resources. All right, so here we go. The production possibilities model is a model of an economy, such as the US economy, but a really simplified version of it. And we're going to make simplifying assumptions. Here are the assumptions we're making. First of all, full employment. We're going to assume that there is no unemployment, everybody is working. And, I forgot to mention this part. We're learning about productive resources. We're only going to be considering one type of productive resource, and that's labor. We talk about labor, that's the most commonly discussed productive resource in economics, and that's the case here too. All right, so we're only talking about the use of labor resources in this economy, and we're assuming that all of the labor resources are being used. Fixed resources. This means that we're going to assume that the labor force is fixed in size, it is not growing. Now, in our real economy, the labor force is growing because our population is growing by a small amount each year. But to simplify things, let's assume this is like a snapshot in time. The labor force is not growing. Fixed technology, we're going to learn more about this in Chapter 2 and other chapters. And what this means is the technology that workers use to produce the products is fixed. It is not advancing. Now, again, in the real economy, the production technology is advancing all the time, and that makes workers more productive. But to simplify, we're going to assume that's not happening right now. Or again, if you prefer, think of this as like a snapshot in time. Now, the biggest assumption of all, get ready for this. You might want to sit down if you're not sitting. Grab the sides of your chair. This is going to be a little bit shocking to you. But we're going to assume that unlike the real economy where there are, tens of thousands of different types of products being produced, we're going to assume that this economy is only producing two products. And wait till you hear what they are. Pizzas and industrial robots. So robots used as production technology to produce things. All right, so companies that produce industrial robots companies that produce pizzas. Those are the only kind of companies in this economy. All right? Only two products. So you're using all of your productive resources to produce some combination of pizzas and robots. Here are the production possibilities. So this is, imagine that instead of an economy, if you prefer, this is a factory that has a fixed amount of resources. The resource we're going to consider, by the way, not all four of them, only labor. So we're only thinking about labor. We're only thinking about what happens when we dedicate so much of our workforce to producing one product and then make changes to that. Okay, and we're only looking at the labor resource at this point. So every worker then is assigned to produce either pizzas or robots. And let's say that this is historical data that we have collected. It would look something like this. Now these are in different units, just so you know, because pizzas, these numbers that you see there, that's in hundreds of thousands. Industrial robots, that's in thousands. So for example, if we're producing at point B, look at column B, if we were there, then our workers would be producing 100,000 pizzas and 9,000 robots, right? That's what that means. All right, so let's see what we can learn from this. Again, this is data that, let's say, has been collected, and this is what it looks like. And it sort of defines the possibilities for us if we want to produce different combinations of pizzas and robots. Here's what is possible given that our labor force is fixed in size. All right, well, let's use the simplest example. Let's look at point A. Now, point A, it looks like we're not producing any pizzas. We're producing only robots. And this is per unit time. It's not actually labeled in the graph, is it? Let's say this is per week. Okay, these numbers represent production per week. Well, it looks like we're producing 10,000 robots per week and 0 pizzas. So that means every worker is producing robots. And it's 10,000 per week, and then 10,000 the next week, and then 10,000 the next week after that. Okay? Sorry about that phone. Okay. So now maybe it looks like people want something other than robots in this economy. Buyers, consumers. And they have a craving for pizzas. And you decide that your economy or your factory should be producing some pizzas every month. All right, well, let's start by producing 100,000 pizzas, and we're going to start next week. All right, so up until now, you've been producing 10,000 robots every week. Beginning next week, you're going to have to move some workers out of producing robots into producing pizzas. And you move enough of them that they're now producing 100,000 pizzas. But look what happened to your robot production. You had to give up some robot production, right? Remember that one of the lessons of this model is opportunity cost. So you could think of the opportunity cost of those 100,000 pizzas that you gain per week as being 1,000 robots. You had to give up 1,000 robots per week in order to gain 100,000 pizzas per week, because you went from 0 to 100,000 per week. All right? So there's an opportunity cost because your resources are fixed. They're limited. All right? So maybe you're producing at point B for a while, and this is weekly production, and it's 100,000 pizzas and 9,000 robots. And that's going on week after week after week after week. And then you're noticing that society wants more pizzas. They want still more. 100,000 per week is not enough. And you decide to increase pizza production, knowing that you're going to have to decrease robot production in order to do this, but you decide to do it anyway. All right? So now let's say you go from point B to point C. All right? You're producing 100,000 robots per week. Now, beginning next week, we're going to start to produce 200,000 per week. So you're adding 100,000 per week. But you have to decrease robot production. But now look what happens. Does this look a little strange to you? When you add the second 100,000 pizzas per week to get to point C, now what is the opportunity cost of that second 100,000 pizzas that you gained per week? It's 2,000 robots. That doesn't seem right, does it? Seems like it should be another 1,000. You went from 10,000 to 9,000 when you added the first 100,000 pizzas per week. Why wouldn't it be going from 9,000 to 8,000? There's a reason. This is the law of increasing opportunity costs, which I will explain. But let's follow this further before I explain it. All right, so now you're producing at point C, and you are the plant manager, let's say that's in charge of the productive resources, and you're producing 200,000 pizzas per week and 7,000 robots, and this goes on for weeks and weeks and weeks, and you're noticing that society wants still more pizzas. Well, you can increase pizza production. You can add another 100,000 per week to get to point D, but you got to give up more robots per week. This time, if you do it, the third 100,000 pizzas that you gain are going to cost you 3,000 fewer robots per week. Do you see how opportunity cost is rising? The more pizzas you produce, and you're moving workers in order to do this out of the robot shop, the more pizzas you produce, the greater the cost in foregone robot production. And then ultimately, if you end up going from point D to point E, you're adding another 100,000 per week, and the opportunity cost now is 4,000 robots. So the question is, why is this happening? Well, think about this. You're the plant manager. And let's go back to point A. Right now, you are producing 0 pizzas and 10,000 industrial robots. In order to increase pizza production from 0 to 100,000 per week, you need to move workers. Which workers would you move first? Speak up, I can't hear you. Oh, that's because this is a recording. Yes, you would move probably the best pizza makers if you could identify who they are. The most productive pizza makers. I mean, it would make sense to do that, right? And you would also try to move the worst robot makers. In fact, if you're using 100% of your labor force to produce robots, then you're forcing some people into careers maybe they're not well suited for. Maybe they're not all that technically adept. But you needed them because you wanted to produce 10,000 robots per week. And so you took them into this workforce and you have them producing robots. Well, you would move them out first, right? So you're not giving up all that much robot production when you move them out of the robot shop because they weren't that productive to begin with. That's who you would move first. And again, also the better pizza makers. So when you do that, the workers you moved to get from point A to point B, you didn't give up, relatively speaking, all that much in robot production. Or the cost was lower than it's going to be the more you grow. All right, now when you go from point B to point C, you go from 100,000 pizzas per week to 200,000 pizzas per week. You're moving more workers out of robots into pizzas. Who would you choose? You would pick the next best pizza makers that haven't already been moved and move them into the pizza shop. So they're relatively productive, maybe not as productive as the first workers you moved, the first batch. And then you would also be moving the next worst robot makers out of the robot shop into the pizza shop. So you'd be giving up more robots than when you move the first batch of people. And then this will continue as you go from C to D. And when you go from D to E, now you're moving all of your workers out of the robot shop into the pizza shop, even your very best robot makers. So the cost to the system, to the plant, when you do that, in terms of foregone robots, is the greatest when you go from point D to point E, as I said, because you're moving your very best robot makers and forcing them to produce pizzas, and maybe they're not very good at pizzas. So this is the explanation for why opportunity cost rises. Now let's graph this. This is a graph where on the x-axis, the horizontal axis, we have numbers of pizzas per week. And on the vertical axis, the y-axis, we have numbers of robots per week. And so each one of the points in the previous table is graphed here. So you can see point A, that would be if you were producing 10,000 robots, 0 pizzas. Point B would be if you were producing 9,000 robots and 100,000 pizzas, and so on. You can see how that works. Well, the way this graph works, you can produce anywhere inside that curve if you want to. Let me just pick a point. Try to identify this point with me. How about 3,000 robots? So find 3 on the vertical axis. 3,000 and 200,000 pizzas. Can you see where that point would be? That would be inside the curve for sure, right? In the yellow area. That means that that is an attainable combination. That means you have enough resources to produce 3,000 robots and 200,000 pizzas. However, if you're inside the curve, you're not using all of your resources. You could be producing more of both of those kinds of things. If you're right on the curve, you're using all your resources. And since the resource in this case is labor, that means you have full employment if you're on the curve. Now here's another observation. How about the point that it's a curve to begin with and not a straight line? It is a curve because of this law of rising opportunity costs, or law of increasing opportunity costs. And we're going to graphically explain them why that is the case shortly. But first, here I have it written out, at least as best I could describe it verbally, this idea of why opportunity costs rise. Why is it the more you produce of something, recognizing that you're attracting resources into this market or recruiting them, and these resources are coming out of some other market, the cost to the system rises the more of that thing you produce. As the production of a particular good increases, in this case it was pizzas, the opportunity cost of producing an additional unit per day, per week, per year rises. For society, now we were looking at a plant, a company that has a plant that produces these two kinds of products, but this applies to an economy too. For society or for the economy, the opportunity cost of each additional unit of pizza is greater than the opportunity cost of the preceding one. As the economy moves from point A to point E, it must give up successively larger amounts of industrial robots to acquire equal increments of pizza. Now let's look again at why this makes it a curve instead of a straight line. There's our production possibilities curve, and there's no numbers here. But what you're doing is looking at what happens as you move from one point on this curve to another point on this curve. The slope of the curve gets more steep. And imagine that you had to pick any point on the curve and draw a line tangent to it. The slope of that tangent line tells you the slope of the curve at that point. And if you're not getting this, it's not, if you're not getting this, if you don't remember what a tangent line is, not a big deal. Let's do it this way. All right, suppose you're at point A. And the other red point is not labeled here, but let's call it point B. Suppose you're going from point A to point B. All right, so think about where you are. Well, at point A, you're really high up on the vertical axis. You're producing lots of robots. How about on the horizontal axis? You're not producing many pizzas, right? A lot of robots, not many pizzas if you're at point A. And if you're going from point A to the unlabeled point B, what's the situation there? Well, you're producing now fewer robots, right? A little bit fewer, slightly fewer, but you're producing a lot more pizzas. You're doubling, you're moving twice as far along the horizontal axis, right? Well, take a look at these green arrows. The horizontal green arrow that points to the right is showing you what you're gaining in pizzas when you go from point A to point B. The vertical, the smaller arrow, which is pointing downwards, that's showing how much you're sacrificing or foregoing or giving up of robots per week in order to gain the pizzas that you're gaining. Well, you can see that robot production is small, foregone robot production is small compared to the increase in pizza production. So let's move a little bit further. So if you end up at this, what's now being called point B, now you have really increased pizza production per week and given up quite a bit of robot production. But imagine you want to go even further to an imaginary point C, which is not labeled here. We're calling it point C. All right, just because of the position on this curve, when you go from point B to point C, what are you gaining horizontally? The horizontal arrow shows you what you gain in pizzas. So look at the size of that arrow. Compare it to the lost robot production. That is the length of that vertical arrow that's pointing downwards. That's how much robots you're losing per week. Now, the loss in robots compared to the gain in pizzas is much greater. And again, that's why a curve represents the law of rising opportunity costs. And here's an explanation of why the curve is bow-shaped. Bow-shaped meaning bowing out from the origin. And in fact, it's a curve to begin with, is the point here, and not a straight line. If it were a straight line, then opportunity costs would not increase. They would remain constant. But they don't. So again, here's an explanation as concisely as I could possibly have worded it. It's bow-shaped in part because different workers have different skills which lead to different opportunity costs of producing one good in terms of another. In addition to the limited versatility of individual workers to produce pizzas or robots, the mix of factor inputs, meaning different types of resources, makes a difference as well. We could have used this or had come up with a similar type of curve or model looking at another factor of production, capital, for example, or land, and then looking at different types of uses of that land or capital. But as I said, we're most interested in an economics course in labor as a resource. Now, what would happen if you had economic growth? So we need to revisit our original assumptions and change them a little bit. What would lead to economic growth? Economic growth happens when this mini economy is producing more of both kinds of products. Well, if you had more resources to work with, more productive resources, that would lead to economic growth. In other words, if labor was not fixed, if labor were actually increasing over time, then you would have economic growth over time. You have more workers to produce both types of products. Here's another way we could have economic growth. Suppose your resource quality was improving. The resource we're talking about here is labor, so this would be if the quality of your labor were improving over time. So this would mean if your labor force in your economy was becoming more well-educated or more well-trained or better experienced, and this is something that happens over time, that leads to economic growth. That's why we measure levels of educational attainment. We measure them in all parts of the country. What is the percentage of the population that has at least a high school diploma? What is the percentage that has at least an associate's degree? What is the percentage of your population that has at least a bachelor's degree or higher? And then these are ways to measure educational attainment. It's one measure of labor quality. And you would want for that to be going up over time. If you do, then that leads to economic growth. And then technological advance. Remember we said this is one of the things that we were holding fixed. Well, if technology were advancing over time, and this is the technology used to produce goods and services, then that will lead to economic growth. Just to take a brief aside, this was responsible for a good amount of economic growth in the 1990s. Technological advance. Think about what happened in the 1990s, or what you know about it. What kind of innovation started in the 1990s? How about the internet, which led to the dot-com boom? And really, what was the basis for that? Well, the basis for it is, and something that has continued ever since, is advancement or increase in state-of-the-art of microchips. The computing power of microchips has been doubling and doubling and quadrupling year to year to year, to the point that you have more and more computing power on a smaller and smaller device. And that's why we could do more with a mobile device today than we could do with a room full of equipment 20 years ago. Well, that really started to accelerate in the 1990s. So any business that made use of computers to produce their product, and just about every business does this now, should have benefited. Each of their workers should have become more productive as there are advancements in computers. And think about any industry and whether they use computers or how important computers are to producing their product. Well, in the 1990s, I worked in healthcare. I worked in a hospital. Hospitals make extensive use of computers. I mean, everything from tracking patient records. I was in the hospital. I was working in a hospital when we made the transition from paper patient records to 100% electronic patient records. This was in the early 2000s. And think of all the efficiency that led to. But it's not just that. I mean, all of the equipment they use is computer-based. Even the most sophisticated MRI equipment and CT equipment, CT scan equipment, it's all computer-based. So as that improves, the productivity of hospitals improves and healthcare organizations in general. How about the financial services industry? How about banking? It's all electronic. So every financial services organization, including insurance and brokerage, all computer-based, should have seen their productivity increase. So that's economic growth in our economy in general too. So anyway, these are the types of reasons you could have economic growth. So what would that look like regarding your graph? Well, let's get back to our fictional economy, where we're only producing pizzas or industrial robots. Suppose our workforce was growing, our labor force. Suppose that's what's leading to economic growth. Well, you just increase these numbers, right? Now, if you had all of your workers producing just robots, they'd be producing 14,000 instead of, I think it was 10,000. And if you shift some of the workers to producing pizzas, now they're producing 200,000 pizzas per week and 12,000 robots and so on. So the numbers are all just larger. You could produce more of both things with the labor force you have because you have more workers. So if you were to graph that, then it's as if your curve is moving away from the origin some. And you can see the rightmost curve is the new curve that is representing after you experience the economic growth. Now there are larger combinations of products, of these two products, that are now attainable. So this is the idea. Now let's get back to the idea that this is an economic model where we made these simplifying assumptions. Some of them you might even say are ridiculous. I mean, how could you have an economy that's only producing two kinds of products? You would never do that, right? Well, okay, let's extend this concept to the more complicated real economy that we have. Let's pick a market, a product market that is growing or has grown recently. So let's say, think of anything that you buy more of now than you bought 5 years ago or 10 years ago, or consumers in general are buying more of. So how about mobile devices? Okay, we're buying more mobile devices now, right? And well, a lot of that hardware is actually produced outside of our economy, although it's designed here. But the software is designed here. Let's say the market we're looking at is software, mobile applications development. So these are software people that write the software that become applications, apps that then can run on mobile devices. Let's say it's that market. And that certainly is a market in our economy that has grown from very small to now quite large. So now there's a lot of workers working in that market, right? Working for companies that develop mobile apps. Let's go back to the beginning. When the first couple software companies decided to start writing mobile apps. And this was a really hot product that people wanted more of. And these were very profitable firms because they didn't have any competition yet. And so they were probably paying above average wages. And so who are the first workers they're going to recruit? Probably the best software developers that were working for other companies producing some other kind of software, maybe like for mainframe systems. All right, so those are the first workers that are coming in. And they're super productive at mobile apps. And they're identified for that reason. You want to hire people that you think are going to be good and interested in developing these mobile apps. Maybe they're not that inspired writing software for mainframe systems. That's been happening forever, right? All right, so now let's say more firms are entering this market and starting to hire more software developers because we just can't satisfy all the consumer need. It's such a hot product. Well, now there's more workers coming into this market and working for these companies to write mobile apps. They're working for other software developers. And think about the opportunity cost to the economy, to the system. Not to any one company, not to any one industry. You have to look at the whole system. Well, the more this market grows up and becomes larger and larger and larger and produces more and more per month and per year, the more workers it needs, which are being recruited out of other markets, companies that were producing other products. At first, software companies, well, you're giving up those other kinds of software. At a certain point, you're going to run out of software developers to recruit, and you're going to start recruiting anybody you can find and maybe figuring you'll train them how to write software for mobile apps. Well, maybe they were better off producing whatever it was they were producing, maybe pizzas or something like that, right? And now the production you gain in training these workers that are not all that adept at writing software to write software, the system is giving up more and more of those other things that were being produced by these workers. The opportunity cost to the system is rising. That's the point. So we're trying to extend what we learned in this economic model, this simple model with just two products in an economy, to the more complex real economy we have. And this is the way it will work. Now that was my example that I used from another source. That was actually not in your textbook. This is the example that is in your textbook. And I'm not going to go fully through this because it is explained in detail in Chapter 1. And I'd like you to read that. But I'm going to sort of just touch on it and show you how this is an equivalent example. In this example, again, imagine that it's one factory that's being converted or it's shifting between truck production and tank production, as might happen if the nation were to become involved in a war and need to start producing more tanks. And so if that were the case, you might go from point A in this example, where this factory was producing, this is daily production, I believe, was producing 5 trucks per day, to point B, where now they're producing 4 trucks per day, but 2 tanks. So the only way to do that is to shift some of the workers. And we're not even getting into the other resources, but you're shifting capital too, right? You're adjusting capital, buying new capital, and so on. Well, just looking at labor, You're moving some workers out of the truck shop or out of producing trucks into producing tanks. So the opportunity cost of those 2 tanks per day that you gained was 1 truck. You lost 1 truck to gain 2 tanks. So you identify your best tank makers first, right? And move them first so that you're gaining a lot of tanks for the trucks that you're giving up. All right, so now you're producing at point B, and that's day by day by day. It's going on and on and on. 4 trucks per day, 2 tanks per day. And now the military wants still more tanks, and you decide to start producing 1 more tank per day. All right, so you go from point B to point C. Now you're producing 3 tanks per day. You're gaining 1, and you're giving up 1 truck per day. Now in this case, the opportunity cost rose, didn't it? Because in the beginning, when you went from point A to point B, you gained 2 tanks for that 1 truck you gave up. Now you're only gaining 1 tank for 1 lost truck. So the opportunity cost is actually rising for you, isn't it? And this will continue to happen. Let's say we reach finally point F, where you're doing nothing but producing tanks. You're producing 5 tanks per day. All right? Well, maybe now the war is starting to wind down and the military doesn't need as many tanks. And so you go from point F to point E. Now you're producing 1 truck per day. How many tanks are you going to have to give up once you move those workers? It looks like half a truck per day, or half a tank per day, right? You go from 5 to 4.5. So the opportunity cost of that 1 tank or that 1 truck per day that you gained when you went from F to E is half a tank, because you went from 5 to 4.5. And maybe you're at point E for day after day after day after day, and now the military is starting to signal to you that they need even fewer tanks. Okay, we're going to start producing 2 trucks per day in our factory. You go from point E to point D. What is the opportunity cost of that 2nd truck that you gained when you went from 1 per 2? When you went from 1 to 2, now what are you gaining? Or what are you giving up in tank production? 0.7 tanks. The opportunity cost is rising. And if you were to go further from point D to point C, when you're gaining that 3rd truck per day, what is the cost of that extra truck when you go from 2 to 3? Now it's 0.8 tanks. You go from 3.8 to 3. See what I mean? So opportunity cost is rising in either direction. And if you're to graph that, it looks just like we've seen before. All the same lessons. Now here, actual numbers are being added here to the graph, to the arrows, whereas before I was just trying you to visualize, does this arrow, the horizontal arrow, look smaller or larger than the vertical arrow? Well, here they're actually giving you the numbers, doing the math, the subtractions for you. But it's demonstrating the same point. So this example demonstrates the same point as the pizza robots example is demonstrating. And this is just going through the explanation, which I'm going to allow you to read on your own. Why does this happen? Because not all resources are created equal. Not all labor is created equal. Some labor is specialized to produce one good better than another. Some workers are more technically adept. Some are more creative, let's say. Some belong in a manufacturing environment. Some belong in a more service-oriented profession, and so on. Again, this is making the point that if you're on the curve, you're using all your resources. If you're inside the curve, you can do it. You have enough resources, but you're not using all your resources. In other words, you have high unemployment if you're at point Y. You do not have enough resources to produce outside the curve, point X, for example. You don't have enough workers to produce that quantity, those quantities of tanks and trucks. If you were to experience economic growth, it's as if this curve is moving away from the origin. Actually, it's not as if it's happening. It is happening. That's what economic growth is. It's represented by this production possibilities curve moving away from the origin, so that at any point on that curve now you're producing more of both things. So since this is a guns versus butter example, tanks and trucks, the guns versus butter debate refers to the debate on how much of our productive resources in our economy should be dedicated to the military and how much should be dedicated to producing consumer goods and services. Now, our federal government doesn't really control what productive resources are used to produce consumer goods and services, but they do control what productive resources are used to produce military goods and services. And if you jump to this last bullet here, you can see that now this is an extreme example, but our biggest involvement in World War II in 1944, at the peak of our involvement, we were using 40% of our productive resources in our economy to produce military services and goods. So in other words, we drafted workers that were producing consumer goods and services out of their jobs into the military, deployed them around the world, and then asked other manufacturers who were producing consumer goods and services to start producing military goods. So 40% of what we were producing, if you include the services that all of the soldiers were producing, made up 40% of our economy. And again, that is an extreme example. We've never been close to that percentage since then. But even today, look at North Korea, a relatively small population, 26 million. Remember, we have 340 million, so they're less than 1/10 our size. They have the fourth largest army. You'll see some numbers on the next slide that'll illustrate this even more. 20% of what they produce in their economy is military goods and services. And that is in what you would consider to be more like normal times. They're not at war right now like we were in 1944. So what's the consequences of this? Well, they're not producing as much goods and services, consumer goods and services, as they should, as their population would want them to. This table shows you the largest armies in the world. Now, this is numbers of soldiers. So it's no surprise that China would be number one and India would be number two. They are the largest two countries in population. They each have about 1.4 billion people. We are number three in population size. We have 340 million people. What might be a little bit surprising is that India is so much smaller than China, the size of their military. You would expect them to be comparable, but they're not. And it's also maybe a little bit surprising that we are more than half the size of China's military, even though we're 1/4 the population. And the biggest surprise, or the biggest number that stands out here, is the fact that North Korea has the same size army as the United States, more or less. Now, that's not to say that they are as well equipped. They are not. They don't have the same technology we have. They don't have the same training. But in terms of numbers of soldiers, they are dedicating as much in terms of labor to their military as we are. We are more than 10 times their size. This is just another illustration of, in various countries, what percentage of their economy the military comprises. And North Korea, far and away, is the most. And you can see in the U.S., only 3.2% of what we produce in our economy is military goods and services. Now, we haven't talked about gross domestic product yet. That's coming up in the next chapter. That's how you measure how much is produced in your economy. Gross domestic product. That's the total dollar value of all the goods and services that you produce in a year. So 3.2% of our GDP is our military. That's what that means. 20% of North Korea's GDP is their military. We're going to stop right here, and we're going to begin part 3 of chapter 1 by talking about different types of economic systems, where what's different is the mechanism that guides economic activity. That is all coming up in Chapter 1, Part C. I'll see you then.